Hello, my good friends. I still remain Dr. D.I. Shul, your lecturer on chemistry on social media. My previous lecture was on periodic table. We defined it. We also saw some of the main blocks, the S, P, D, F blocks, and the elements that are contained in them. But right away, we shall discuss some topics in organic chemistry. These are titled Alkanals and Alkanones. Alkanals and Alkanones. So listen carefully as I go through what I have. The alkanals are also called the aldehydes, while the alkanones are known as the ketones. Some elements, for example, oxygen and nitrogen, they possess a lone pair of electrons, which qualify them to undergo coordinate combination. Therefore, an oxygen atom can form a double bond with a carbon atom to produce a carbonyl group. And this is also called the keto group on the board here. Oxygen can contain a lone pair of electrons. Therefore, can combine with carbon in a coordinate combination to form a carbonyl group called ketone. Now, the carbonyl group is the functional group for both aldehydes and ketones. Now, if an organic molecule or an organic compound containing carbonyl group is bonded to only one alkyl group or only one phenyl group, and then one or two hydrogen atoms are attached to that organic compound, then it is called an aldehyde or alkanal. So, for example, on the board here, now the C double bond O is the alkyl group, which is the functional group. Now, this organic compound is attached to one alkyl group, which is the R, and then one hydrogen atom with the keto group here. It's either written this way or this way, whereby the R here is the alkyl group or the phenyl group. The R being equal to H means that hydrogen can take the place of R in certain cases. Now note that in aldehydes or in alkanals, the functional group is also the carbonyl group, which is also at the one end of the organic compound. Look at it now. This is one thing you can use in differentiating alkanals and alkanones, because they both have the same functional group. For you to know that this organic molecule or compound is aldehyde or it's a ketone, by this you will know them. Now, if it is alkanals or the aldehydes, the R, which is the alkyl group or the phenyl group, is attached to one end of the organic molecules. Then the other end contains hydrogen atoms. But in the case of alkanone, as we go next time, both ends, both terminals are containing other alkyl groups or phenyl groups. Now look at the example here. Functional group, of course we know it, is carbonyl group, and this is the structure of the carbon group, the carbonyl group. This bond is attached to a phenyl radical or an alkyl radical. So now, let us see structurally some of the organic molecules. We have, from methane, we have methanol. Methane is alkane series. So the name is derived from the alkane series. So the E, which is the ending part of the methane, is being replaced by Al. Now, methane becomes methanol. ethane becomes ethanol. Propane becomes propanol. Now, structurally, you see that H bond C 0H. This is the structure of methanol. Carbon atom here, three hydrogen atoms, we see H3, and then the carbonyl group here at the one end is ethanol. Then also we have propanol. We have the three carbon atoms attached to the first carbon atom, two hydrogen atom, 1, 2, 3, three hydrogen atoms, two hydrogen atoms to the second carbon atom, third one carrying the carbonyl group and one hydrogen atom. This is propanol. Now, you can also convert the structure to be in this way in the second case. Instead of slanting the bond, double bond, it can be straight up like this, perpendicularly to the carbon atom. In this case, also in this case, also in this case. So these are examples of aldehydes, which are called the alkanals. So we have propanol, butanol, pentanol, hexanol, heptanol, octanol, decanol. All these are members of this alkanol series. So we'll see next time we talk about the ketones. So like it, please comment and follow me. Thank you.